We are covering rigid body rotation, specifically angular motion and the instantaneous center of zero velocity, a key topic in the dynamics section of the FE Civil exam. These concepts are found in the Dynamics chapter of the NCEES FE Reference Handbook. First, let's define our terms. Angular velocity, omega, is the rate of change of angular position, theta, and is given by omega equals d theta dt, with units of radians per second. Angular acceleration, alpha, is the rate of change of angular velocity, so alpha equals d omega dt in radians per second squared. For any point on a rotating body, its linear tangential velocity is v equals r omega, where r is the distance from the center of rotation. That point also experiences two components of acceleration. The tangential component, A tangential, is caused by the change in speed and equals r alpha. The normal component, A normal, is directed towards the center of rotation and is caused by the change in direction, equal to r omega squared. The total acceleration is the vector sum of these two components. From a kinetics perspective, for a rigid body undergoing pure rotation about a fixed axis, the sum of the moments about that axis equals the body's mass moment of inertia, I, times its angular acceleration, alpha. This equation, sum of moments equals I, alpha, is fundamental for solving problems involving forces that cause rotation, like a pulley with a hanging weight. Now, let's discuss a powerful shortcut for velocity analysis, the instantaneous center of zero velocity, or ICZV. For a body in general plane motion, there is a unique point at any given instant that has zero velocity. The entire body can be considered to be in pure rotation about this point at that specific moment. To find the ICZV, you need the velocity vectors of two different points on the body. The ICZV is located at the intersection of the lines drawn perpendicular to these velocity vectors. A classic exam problem is a ladder sliding down a wall. The top of the ladder moves vertically down the wall, and the bottom moves horizontally along the floor. The ICZV is found where the perpendicular from the floor and the perpendicular from the wall intersect. Once you find the ICZV, you can find the velocity of any other point on the ladder using v equals r omega, where r is the distance from the ICZV to that point. A special case is a wheel rolling without slipping. The point of contact with the ground is the ICZV, meaning its instantaneous velocity is zero. This simplifies things greatly. The velocity of the center of the wheel is simply v equals r omega. A major exam trap is units. All the rotational formulas in the NCEES handbook require angles to be in radians, not degrees. If you're given revolutions per minute, or RPM, remember to convert it to radians per second by multiplying by 2 pi over 60. Also, be consistent with your sign conventions for clockwise and counterclockwise rotation. A common point of confusion is mixing up the normal and tangential components of acceleration. Remember that tangential acceleration depends on alpha, while normal acceleration depends on omega squared. For a memorable shortcut, think, to find velocity with ease, draw perpendiculars from the v's. Where they meet is the IC. This phrase will help you remember the graphical method for locating the instantaneous center of zero velocity, which is often the quickest way to solve complex velocity problems on the exam. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.